Hey everybody, wanted to go ahead and do a video on automatic temp controls. This is going to be where it's going to control the heat and the air conditioning to get the desired temperature of the driver and the passengers, and depending on if you got zone control or not, is how that's going to divvy it up. So let's go ahead and get started with the PowerPoint. We'll go here, and we're going to go ahead and get it going. So let's go ahead and get started. All right, so basically the purpose of it, the air conditioning, like I said before, it's not just air conditioning. We're actually talking both. We're going to help with the temperature and also humidity. Remember that air conditioning helps with the dehumidifying, and we're going to bring it down to the proper temperature. Now, these are going to be more than not, they're going to be either a dial or a push button. You push in the temperature that you want, and the vehicle's computer is going to try to keep it at that amount at all times. So it's going to try to say you want it at 71 or whatever, it would try to keep it as much as possible at 71. So here's, an automatic display panel that, says, okay, the driver is at 71 and the passenger is at 70. So this would be at least a minimum of a 2-zone system. So this can be done, and my car actually has this capability. I just dial in my temperature, and the passenger can dial in their temperature. Now, there are different sensors in the car, and this is where we're going to get into when it will, the sensors look at the outside temperature, and it also looks at the inside vehicle temperatures to see if it can figure out how to bring that temperature that was programmed in to where we need it inside. Now, remember that if the temperature outside is very, very hot, and our pressures have got to be quite high on the high side so it can do that dissipation of heat. If it's cold outside, and let's say its outside temperature is 60 degrees and we want 71 on the inside, well, we can use some of that outside air to get it to the cool spot that we want it to be at that temperature. Plus, we're going to add in that heater also. And then we have a discharge discharge. Well, just like we take temperatures of the registers at the dash, it actually has a sensor pushing out there to see what the temperature is pushing out. We're looking at the evaporative temperature too. This is used in a couple of different ways. We're looking at the temperature leaving the evaporator, and also we're going to use that temperature sensor also for making sure we don't freeze up that evaporator also. Then we have a sun load sensor. Sometimes it's all called the solar sensor, and it normally is mounted on the top of the instrument panel, and it used to measure the radiant heat load that it might cause an increase in the inside of the vehicle also. Infrared sensors are mounted in the control head, or sometimes in the headliner there, to get the kind of temperature on that also. And then we have an air conditioning compressor speed sensor on some vehicles. This is to make sure that the belt isn't slipping, and Toyota is famous for this, where it has an RPM signal on the compressor, and it has an RPM signal that it measures from the ECM to see if it's balanced. If it sees that that belt is not turning the compressor, then it's going to shut down the compressor. And then we have the coolant temperature sensor, like we have just similar, or we might just use one especially on your network systems, where we borrow the temperature sensor for, that was used in the ECM for the engine management system, as far as the fuel injection and the timing. We'll use the same sensor to monitor the temperature of the engine. Also, we can use this in several ways. We can use it for, okay, do we have enough heat to make that heater work? Also, is it the car getting too hot, and maybe we'll shut off the air conditioning, because air conditioner puts a load on the transfer of heat also. And then we have some air quality sensors, which detect the carbon, hydrocarbons, I'm sorry, and the ozone. These are sensors that could be, but few cars have them right now. But there is talk of more capabilities of this. Newer cars are starting to show up with a few of these also. And then we have a few vehicles use the relative humidity. Again, remember, if it's really humid outside, that's going to put a little bit of a load on the air conditioning system also. So it has that also. And a few vehicles use that are equipped with a global positioning sensor, okay, for navigation. Will actually be able to show the sun position. That way it can actually help with that the temperature inside the car too. So there's all kinds of things that we use as far as sensors on a vehicle. We kind of went over a little more than just air conditioning, but you kind of get the idea. There's a whole lot of sensors on the vehicle, and depending what kind of system we have is how many sensors we might have. Now, I'm not saying that every car is going to have all of these sensors. No, not at all. Some will adopt some of these sensors and some will not. So here's an example of an outside temperature sensor that's kind of mounted right before the radiator. This is going to give a sense of what the temperature is outside. And you see right next to here my condenser. It's right in front of the condenser. And then we have airflow. Airflow sensors will be in the air box area, and some will be on the outside air coming in for the fresh air, and then some will be on. We might have another one that's in the inside, and also called the recirculation sensor. So we could actually have a sensor, a recirculation door sensor, or a heater door. We could actually have a heater door sensor also. We can go crazy on all these different sensors as we go along. Then we have actuators. The actuators are usually they are a dual position actuator, and able to move and open and close doors. Some have 3 positions to them, and you can go like at a 45, a 90, and maybe go all the way over to another degree, maybe 135-ish. And then, we can have a variable position actuators that are capable of doing this, whole 360 type of situation. So here is a 3 actuators. I actually have an air box in the room that I can actually show you these different actuators that are actually moving certain doors to make it to where we can get the right blend of what kind of air temperatures we want to have. So the control head provides the switches and the levers. Sometimes it's just turn it on. Sometimes the computer will drive the speed of the blower motor, or some cars we can override that, or we can actually push a switch or move a dial or move a lever to make that happen. And then we will have an on-off type switch like that, and then we can actually sometimes actually move it to where we can do the outside blend, uh, go to the defrost mode, the floor mode, pretty much the same stuff we did with the manual controls, but a lot of this will be pretty much automatic. We just say defrost and it automatically run instead of having to move a lever all the way over or pull a cable all the way over. So here's a block diagram showing the inputs into the actual electronic control assembly and the outputs that are involved in it. So we have inputs coming in, like our sun load sensor, and then our automatic temperature control sensor. So all these sensors on one side, and then we have an electronic control module. Sometimes they call them a BCM. And then it actually does a calculation and it says, okay, I want to have the blower motor at this particular speed. And I want to have the air temperature control actuator door at this degree. I want to have the door motor for the mode door to be at a certain position. And maybe I want to defrost door on. We might want the heater and the AC going at the same time and for the inlet. And then we'll have that control of the compressor, whether it be always on or, it'd be a cycling type system where it cycles that clutch. So all of this, and then a lot of times it doesn't show here, it'll be a feedback. And that feedback gives information back to the computer, said, okay, I got it to where I want it to, or I need to do this little tweak to it. Now, just like some of our manual control systems will have a filter, an air filter. And this, of course, it'll absorb, different types of odors, and will have particulate that will take some of the particulate out of the air that's inside the car. Early on, we didn't have anything like this. We had outside air, and that air was whatever was outside coming in. There is a lot of advantage in the newer cars of making sure the air stays cleaner, and it makes it better for us health-wise. Then, some of the filters will be under the dash. Some will be in the glove compartment, so it could be either way. It just depends on your vehicle and how it's mounted. It shows kind of slide-ins here, but sometimes especially under the hood, it'll be a set of screws you got to take off to get to the filter itself instead of just a slide in and slide out. So it just depends on the vehicle you have. And here's just a quick little video of removing an air filter. Some of them you got to take up a few things, and then you got to flip a few things down to remove one filter out, and then to get it back in, you put a new clean one with your Febreze or whatever you want, and then you got to put the screws back on. So this one, you actually had to take the glove box out to get to it. Some are right under the panel underneath, and they're right under the glove box. It just depends on which one you have on that particular vehicle. So how do we know how to diagnose these? A lot of times we'll use a scan tool, and a scan tool, sometimes it has to be a factory scan tool, but more and more aftermarket scan tools are getting a lot of this information. So it makes it nice. We can actually look at the door positions, the temperatures. We can actually manipulate it if we have a bi-directional scan tool, and we can actually move the doors and calibrate the doors. And if you ever put in a new actuator motor, you have to calibrate that. And there's actually a procedure for doing that, and you need to look up the documentation and get that. Oops, I went the wrong way. All right, and here's showing the music as Tech 2 scan tool. It's a factory scan tool for the General Motors, and they're going through the setup to see how, it kind of gets information. I should put it that way. So whenever, like always, whenever we go through a concern from the customer, we want to go through the steps. So first, we want to verify the concern. We want to make sure that it's actually doing it at that time. If you get some of these intermittents, it gets to be a little bit hairy. And what I mean by that is it gets to where it gets a little bit difficult to find it if that's not happening at that time. So you want to verify concern, and then you want to perform a lot of visuals. A lot of times you can find a lot of this stuff right off the get-go. Like I've said a few times, I do some really quick checks. I look under the hood, make sure everything's plugged in, make sure all the hoses are in place. Sometimes I'll just take, with the customer standing there, I'll just take an infrared gun, hit right at the center registers to see what the temperature actually is. And most of the temperature guns actually have a actual hold mechanism, so you can actually show the customer, what the temperature is actually on at that time. So using a scan tool is a great source for a lot of things, especially because more and more computer controls are, being used in a lot of different parts of the vehicle nowadays. So using a scan tool, because our automatic climate controls systems will set a DTC, and it will give you an idea of what direction to look. It doesn't tell you to replace this part. It says, okay, I have a problem with this actuator motor, and you have to go in there and to diagnose it. Sometimes it's a matter of sweeping the motor. Sometimes it's a matter of calibrating the motor. It really depends on it. Sometimes the motor just dies. And then we have looking at the stored codes, if there's any that is left over. I tend to look at the codes, write them down, and then clear them out, and then run it for a while to see if any codes come back. I have found in my time as a tech that some techs do not clear out old codes. And if you get into some actuator door, that they may not have actually, an actuator, they may not have calibrated it, just stuffed one in there saying, okay, it's fixed, and out the door it goes, and they haven't calibrated. So now we have a problem with the stored code and the actuator not calibrated. And you can actually pick up some of that by looking at that information. Also, a lot of times your actuator doors will not work properly unless all the codes are cleared out too. So it's a step, like I said, you have to go through the steps. Okay. You want to make sure afterwards that you clear out all the codes at the end of the job that you're doing. That way you don't have some leftover for another tech. And like I said before, sometimes if you don't clear the codes, the system won't work properly. So kind of just summarizing it up, the automatic temperature controls, or the ATC, a lot of times we call it, has sensors in it, and it can actually check for DDCs, diagnostic trouble codes for you to help you out. And there's a bunch of different sensors on it. Of course, the sun load sensor, the evaporative temperature sensor, ambient temperature sensor, outside air temperature. We can have an in-vehicle temperature sensor. We will, especially on the automatics. Sometimes we'll have infrared sensors, and we will use the coolant sensor a lot of times on the actual engine management part. And some systems use a compressor speed sensor. Like I said, some of the Toyotas were really famous for that, to detect if the belt is actually slipping or the compressor clutch is slipping itself too. So these are a few things that could happen. The heater core is placed downstream of the evaporator and the airflow. This is the way it's staged, so it goes on through. And then a lot of times we'll have one or two doors to actually get it in the temperature way. And then we have blend doors, like we've talked about before. In many vehicles, HVAC is capable of supplying a discharge air of more than one temperature to different places. You get your zone control systems where you can have it to, and they talk about dual zone control, but sometimes you'll actually have a dual zone up front, and then you have possibly a zone in the back too. So there could be 3 zones part of that. So diagnostic steps, you definitely want to follow the steps. You want to verify the customer's concern, perform a thorough visual inspection. I didn't do a very good job on that typing. And then, retrieve the diagnostic trouble codes, check for data as displayed on the scan tool. And it depends on the scan tool how much you can do. If you're using a generic scan tool, an aftermarket one, sometimes you can't grab all these features, but if you have a factory scan tool, a lot of times you can. So I have a few kind of animations that show some of the temperature, the heat animation and stuff like that. So let's go ahead and watch a few of those. Here is just a quick little one. So it's showing the heat, so it's actually going to the floor. This one actually the cool part. So it's actually opening the doors, going through. Temperatures down. And just because the discharge temperature is, doesn't mean that's necessarily what the inside temperature is. Your discharge coming out, depending what heat load you have inside the car, can be a little bit different. And then we have the blend, and we'll actually turn that on, and we'll blend it through the heater and the and we'll actually the heater and the air conditioning together. And then we have, the humidity, which actually is, I've talked about this before, trying to get it to where we can get the moisture out of the system to dry it up a little bit better, to make it feel a little bit better. And then we have the ATC sun load. I hope that was beneficial. I have a quick little video, but I'm not sure this is going to work, so I'm going to stop it for a second here. I do know I have to turn on the sound, share the sound, or else it won't go through. So I'm going to go ahead and restart it now. Let's see, I should be in the share position right now. I believe I am. Not, we'll have a really short one on this, right?
This is a video by Rich Pin. Today we're working on a Nissan Altima. Now what we're having problems on this car is that we don't have any heat. And the reason being is we have air trapped in the cooling system. It's very common on these 02 to 06s to trap air. Now, to get that air out, the first thing we're going to do, in my case, I'm going to drive the car up on a slope here. Now, if you don't have a slope to drive the car on, you can put it on some ramps. Now, once the car is up on a ramp or a slope, make sure the engine is cold and remove the radiator cap. Next, we want to fabricate a horseshoe-shaped piece of wire about 2 millimeters in diameter, and we want to put that right underneath this part of the cap right here. Just like that. Now we want to put the cap back on the radiator. Next, we need to remove the overflow hose from the radiator. There's a little clamp right here. And once that clamp is off, we can remove the hose. Now the next thing we need is an accessory reservoir, like I've got here, or you can convert a plastic jug into one. And we're going to hang it right up here on the hood latch. It's right up there. And we're going to take the hose from the container right here, and we're going to go right down to where we took off the hose to the reservoir. And we'll put this little clamp on and tighten that up. Next, we want to take some coolant and pour it into our container. Okay, I got about 1/4 of a container there. Okay, now the next thing we're going to do is start up the engine, put the heater on, and put the blower on full. Now you want to run that like that, and occasionally you can bring the RPMs up. You can rev up the engine, and then you're looking for the bubbles that come up the hose. And when you get the temperature up so the fan comes on, the fan on the electric motor, the radiator fan, when that comes on, usually you're done, and that's it. And then you want to let it cool down, and then you can take your hose off and take your radiator cap on, and then check your fluid level, and that's it. You should have purged all the air out of the system. Now don't forget to remove the piece of wire that you put under the cap before you're finished. And that's all it takes to purging the air out of your Nissan Altima.
All right, I hope that was beneficial. I really,
Drinking the
sometimes
Hey guys,
just
Chris
going
Fix here, and
into,
today I'm going to show you.
sorry about that. Sometimes just doing some, different types of procedures can help. Now that was a little, kind of backyardish, but that's one way of doing it. The other way is they make some really nice funnels, and these funnels can help you bleed some of that air out also. And some vehicles actually have a little bleed screw. A Honda did a lot of them, Nissan did a lot of them there for a while, where you can actually bleed the air out of trapped areas. So we're just trying to get as much air as possible, because if we don't have the air out of the system, we can't, transfer heat, both with the engine, and also we can't get the heater to work properly. Again, when we talk about HVAC, we're not just talking about the cooling part of it, we're also talking the warming part of it too. All right. I hope this was beneficial. If you enjoyed it, please, definitely let me know. And I also, if you could, I'm just saying, if you have any questions, please feel free to reach out to me, and you can get me through my email, or you have my phone number also. So until next time, we'll be talking. Bye for now.